So the typical form of Clairaut's equation is y equals to ex plus some function of p. Of course, we know p stands for dy by dx. We have p equals to dy by dx. Now it's a special case of ordinary differential equation of first order and higher degree, which are solvable for y, which we have discussed in one of the previous videos. And how we solve this kind of equation, which is solvable for y, we take a derivative of the equation with respect to x. So if we take derivative of this equation with respect to x, we will get dy over dx equals to derivative of px plus function of p. Let us give the original equation name as the general form of Clairaut's equation as 1, right? Now we're taking the differentiation, but before that dy by dx stands for p, so we are replacing it by p. So derivative of px, okay, first uv rule, first function p as it is, derivative of x is 1, then plus second function as it is, derivative of p with respect to x, dp over dx, plus when you have got derivative of f with respect to x, we will apply chain rule. We don't know, f could be any function, so derivative of f with respect to p, we will denote it by f dash p, chain rule, multiplied by derivative of p with respect to x, right? So p into 1 is p and this one is p, so they will cancel out. So we'll cancel out p by p. So this equation becomes 0 is equals to x dp over dx plus f dash p, a function of p, and this is dp over dx. In these two terms, we are having dp by dx as common. Okay, so we're writing this right hand side on left hand side. So we have dp over dx and first factor, and second factor will be x plus f dash p equals to 0. So this equation has two factors. One is dp by dx and another one is x plus f dash p, right? And we already know that the factor that involve dp by dx, if we equate it to 0, okay, we get a general solution using this factor. So taking dp by dx, here you have dp over dx equals to 0. This is simply a separable equation of first order and first degree, first order, first degree ordinary differential equation of separable form. And solving this equation, so we can rewrite it as dp equals to 0, right? So this is separable form. We simply integrate it. We have integration of dp is equal to integration of 0, integration of dp. This will give me simply p, and integration 0 c. This is arbitrary constant. So the solution of this first order, first degree ordinary differential equation with p as dependent variable, x as independent variable, is simply p equals to c. This is our equation number 2. And we get the general solution of the Clairaut's equation, the given equation, by eliminating p from equation number 1 and 2. We simply will replace p by c in equation number 1. So this one is general solution of Clairaut equation by eliminating p between 1 and 2, and this will be simply y equals to, you have cx plus some function of c. So please, the conclusion of the story is that, if the equation is a Clairaut equation, we need not to do all these calculations. Simply in the given Clairaut's form, simply replace p by c, where c is arbitrary constant, and the solution will be y equals to, cx plus function of c. Now, using the factor that to involve had dp by dx as a factor, we got the general solution. The second factor, x plus f dash p, right, which does not involve derivative dp over dx. If we equate it to 0, okay, using it, we find the singular solution of the given Euclid's equation. Now, singular solution of a differential equation is a solution which does not involve any arbitrary constant, right? So let us see how we can find the singular solution of Euclid's equation. So the factor is x plus f dash p equals to 0. This is our equation number 3. Now, by eliminating p between equation number 1 and 3, we get the singular solution. So the singular solution is obtained by eliminating p between equation 1, the Euclid's equation, and equation 3. Equation 3 that we obtained using this factor. But there is an alternative method to find the singular solution, right? Now, equation number 1 and the general solution is having similar form, right? So, in singular solution, we can replace the first equation by y equals to cx plus fc. Let us give it a new name, and this is equation number 4. Now, suppose we differentiate equation number 4 with respect to c, differentiating this equation with respect to c. So, what will we get? Derivative of y with respect to c, it will be 0. Derivative of cx with respect to c, x will be treated as a constant, and derivative of c is 1, plus derivative of fc with respect to c, this will be f dash c, and we can write it as f plus f dash c is equals to 0. Now this equation which we are giving name 5 is similar to x plus f dash p equals to 0. Okay, so singular solution either we can obtain by eliminating p from equation number 1 and 3, or by eliminating a similar set of equation. First equation is the general solution of Clairaut's equation, and the second one is, obtained by differentiating the general solution with respect to arbitrary constant. In this case, we will eliminate C between equation number 4 and 5. Let's take a couple of examples. So this is our first example, and we have to solve the equation. The equation is y equals to px minus e raised to the power p. Okay. Now compare with the the general form of Clairaut's equation. We having y equal to px minus some function of p. So clearly this is Clairaut's equation. So it will have two solutions. One will be its general solution. The another one will be singular solution. How do we find the general solution? To find the general solution of Clairaut's equation, we simply replace P by C. So the general solution of this Clairaut's equation will be y equals to p will be replaced by c, where c is arbitrary constant, cx minus e raised to the power c. So the original equation is equation number 1. This is e raised to power c, and this is our equation number 2. So y equal to cx minus e raised to power c is the general solution of the given Clairaut's equation. Now let us find the singular solution, right? So equation number 2 is same as equation number 4. To find the singular solution, we will differentiate equation number 2, that is general solution, with respect to arbitrary constant c. So we differentiate equation 2 with respect to arbitrary constant c, treating it as a variable. So this will be derivative of y with respect to c, it will be 0. Derivative of cx with respect to c, x will be treated as a constant. Derivative of c is 1 minus derivative of e raised to power c with respect to c, it will be e raised to the power c. Let us simplify, let us solve it for c. So this becomes e raised to the power c equals to x. Taking anti-log, this will become c equal to log of x. This is our equation number 3, and this is same as the standard form here x plus f dash c equals to 0. Now we will eliminate c between equation number 2 and 3 to find the singular solution. And in this case, simply we can say we will replace c by log of x. So our we are looking for the singular solution, and the singular solution will put c equals to log x into, so this will be y equal to log of x into x minus e raised to the power log of x. Okay, and now exponential and log are inverse functions, so this will be simply y equal to x log x minus x. So this one is the singular solution of the given Clairaut equation. Let us take one more example, and in this example, we have to solve this equation. This one is sine px into cos of y minus cos px multiplied by sine y is equals to p. Okay, now in first look, this is not a Clairaut's equation because this is not in the general form y equal to px plus fp. But giving a second look to the form of the equation, we can apply here sine a plus b formula. So this will become sine of px minus y. Sine a cos b minus cos a sine b, and this one is equals to p. Now we can take inverse, sine inverse both sides. So this will become px minus y equals to sine inverse p. And further simplifying, this will become y equals to px minus sine inverse p. So this is clearly Clairaut's equation, y equal to px minus some function of p. In this case, the function is minus sine inverse p, right? So first we find the general solution, and general solution of this Clairaut's equation will obtain simply by replacing p by arbitrary constant c. So the general solution will be y equals to cx minus sine inverse c. This equation number 2 is the general solution of the given Clairaut's equation. Now we are looking for the singular solution. What do we do to find the singular solution? First, we will differentiate the general solution, that is equation number 2, with respect to arbitrary constant c, right? So derivative of y with respect to c, it will be 0. Derivative of cx with respect to c, it will be x will be treated as a constant. Derivative of c with respect to c, this one is I beg your pardon, this one is 1, and minus sine inverse c. Derivative of sine inverse c, it will be 1 over square root of 1 minus c squared. Now let us simplify, solve it for c variable, right? So this will become x equals to 1 over 1 minus c squared. Squaring both sides, this will be x square equal to 1 over 1 minus c squared. We can further rewrite it as 1 minus c squared is equal to 1 over x square. Further simplifying it, it will be c square equal to 1 minus 1 over x square. And this one is equals to x square minus 1 over s squared. Solving it for c, this will be c equal to plus minus square root x square minus 1. The denominator will be simply x squared. Square root, it will be simply x. So this is the value of c. Now we'll obtain this is a equation number 3, and we will find the singular solution by eliminating c between equation number 2 and equation number 3. So our singular solution will simply become y equals to plus minus square root of x square minus 1 over x. This x is out of this square root multiplied by x. This minus sine inverse, again c will be replaced by plus minus square root of x square minus 1 over x. X and x will be cancelled out. So the singular solution will be y equals to plus minus square root of x square minus 1 minus sine inverse square root of x square minus 1 over x. So in this video, we learned what is a Clairaut's equation and how to find its general solution and the singular solution with the help of a couple of examples. Thank you.